Let's practice a little bit. But before we do that, let me give you some guidelines that'll help you out. Remember, I mentioned in the previous video about the term conjugate acid-base pairs. Remember how we linked the acid on one side with its conjugate base on the other, and then we linked the base on one side with its conjugate acid on the other side. So here's the deal. A conjugate acid-base pair, so the two things that are linked, are two chemical substances that differ by one proton, okay? Always differ by one proton. The acid has one more hydrogen and one less negative charge than the base. And you saw that when we did the example. We said the HCl and the Cl minus. The acid has one more hydrogen than its conjugate base and one less negative charge, okay? The base has one less hydrogen and one more negative charge than the acid. So when we showed this scenario here, we said that water was the base and that the hydronium ion was the acid. So the base has one less hydrogen. Notice it has one less hydrogen and one more negative charge than the acid. Yep, so it has one more negative charge, so the extra negative canceled out the positive, and that's why this is neutral. You can also see that with this scenario here. Which one's going to be the acid? This is going to be the acid because it has one more proton, one more hydrogen than the base. So this is the base, this is the conjugate acid. This has one less negative, this has one more negative. What about this? H2O, OH minus. Remember we saw that also. Which one's going to be the acid? This one's the acid. It has one more proton. And it has one less negative charge than this. This has an extra negative, this one doesn't. This has one more proton, this has one less proton. So that's the way I want you guys to look at it. And what I'm going to do is I'm going to put a couple of things from a handout. I'll upload that handout to your chapter, to your module, so that you can practice with this. This is one I normally give my students when we're on ground. Let me find a few of them here for you guys to practice with. All right, or we'll do it together. All right, so I've got this here, and I want you to get the conjugate acid. So I'm telling you that this is a base, and I want you to get the conjugate acid. And then let me find another one. I've got this here. I'm going to tell you that this is an acid, and I want you to get the conjugate base. Okay, so remember the definition. The conjugate acid-base pairs always differ by one proton. The acid always has one more proton than the base. The base has one more negative than the acid. Okay, so this is the base. The conjugate acid has to have an extra proton, and it's going to have one less negative. So we're going to add the proton. We're going to have one less negative, and there we go. We have the bicarbonate or the hydrogen carbonate polyatomic ion. So this is a conjugate acid-base pair. All right, what about this one over here? HCN. That's the acid. The conjugate base is going to have one less hydrogen and one more negative. So we get rid of this H. We give it an extra negative. There's the conjugate base. Okay? So that worksheet is something you guys can practice with. All right, and then I'm going to give you an equation here. Let me find one that is a little tricky. Yeah, this one's good. HiO3 plus HC2O4 negative. We'll do a double arrow here. IO3 negative plus H2C2O4. Okay, so what we want to do is link up the conjugate acid-base pairs. Remember, they differ by one proton, guys. They differ by one hydrogen. So what are the two things that differ by one hydrogen? You can immediately see that HiO3 and IO3 differ by one hydrogen. And HC2O4 minus and HC2O4 differ by one hydrogen. Okay, so we've identified the acid-base conjugate pairs. Now, our job is to look at this and say, okay, which one of these two is considered the acid and which one of these two is considered the base? Because one of them has to donate a proton to the other. Now, they both have hydrogens. So now what we have to do is look and see what they became. Look, this HiO3 became IO3 minus, meaning that the only way this became this is if it donated a proton to this. And this HC2O4 must have picked up a proton to become this, because this is just one hydrogen, this is two hydrogens. So therefore, since this donated a proton, by definition, this is the acid. So since this picked up a proton, since it accepted a proton, this is the base. Okay? Once we've determined who's the acid and who's the base, we look over on that side, we say, okay, this is the acid, this would be the conjugate base. Conjugate base, because remember, that's your acid-base conjugate pair. These are two. And if this is the base, then what it becomes over here, this is the conjugate, I can't fit it all in, conjugate acid. Okay, so you need to be able to look at equations like this and be able to determine who's the acid, who's the base, who's the conjugate acid, who's the conjugate base. And the best way to do it is to link the two that differ by one proton. Link the two that differ by one proton. So once you find the conjugate acid-base pairs, then you can take a look and see, okay, what happens to this, what happens to this, and you can figure out who's the acid, who's the base, who's the conjugate acid, who's the conjugate base. Okay, good. New topic. On your what you need to know list, there is the term amphiprotic. So let's write that down and see what that actually means. And you've actually already seen this in an earlier video about water. So let's see here. Amphiprotic substance. You know what an amphiprotic substance is. What is that? That is a substance that can behave, it can behave as an acid. That means it can donate a proton, and it can also behave as a base. It can accept a proton. We saw that with water. We saw that water can donate a proton and then it ends up being the hydroxide polyatomic ion, or it can accept a proton and it becomes the hydronium polyatomic ion. So we saw that already in a previous video. Let me give you another example of an amphiprotic substance. You can have the bicarbonate ion, HCO3 minus. This is amphiprotic. What can it do? It can donate a proton and become CO3 minus, or it can accept a proton and become carbonic acid. Okay, so this is an acid-base conjugate pair. This is an acid-base conjugate pair. In this scenario, this is an acid, and this is the conjugate base. In this scenario, this is a base, and this is the conjugate acid. Conjugate acid. But what did we see? We have the same substance sometimes behaving as an acid, donating a proton and becoming this, sometimes accepting a proton and becoming this. Anytime you have a substance that can do both, can sometimes behave as an acid, sometimes as a base, it's called an amphiprotic substance. We saw that with water. We saw that with the bicarbonate ion. There are several other examples, and you'll see that the more you practice. Okay, good. Next video, we'll probably deal with diprotic, triprotic acids, and I'll see you then.